Have you ever stopped to consider how often you interact with artificial intelligence without even realizing it? From the smart assistant on your phone to the search engine predicting your next query, natural language processing, or NLP, is constantly at work behind the scenes. At its core, NLP is a specialized field of AI that gives computers the ability to understand, interpret, and even generate human language. Think about that for a moment. Machines comprehending the nuances of our complex communication. This presentation will peel back the layers, starting with the foundational concepts, moving through the evolution from traditional methods to cutting-edge deep learning architectures, and finally, exploring its profound impact on our world. Get ready to dive deep into how computers learn to speak our language. Before computers can understand us, they first need to break down the incredibly complex structure of human language. Unlike the precise logic of code, human language is full of ambiguity, context dependency, and subtle meanings. It's not just about words, it's about how words are used. To tackle this, NLP employs several foundational steps. First, we have tokenization, which involves splitting text into smaller units like words or phrases. Next comes lexical analysis, which often includes stemming or lemmatization, reducing words to their base or root form, like running to run. Finally, syntactic analysis, often through part-of-speech tagging, identifies the grammatical role of each word, distinguishing nouns from verbs and so on. These initial steps are like learning the individual notes and chords before you can appreciate the full symphony of language. NLP has undergone a dramatic evolution. Initially, approaches were largely rule-based, relying on handcrafted rules and regular expressions to parse text. While precise, these systems were brittle and struggled with the vast inconsistencies of human language. The next phase introduced statistical methods, such as n-grams and TF-IDF, which analyzed word frequencies and probabilities. These were more robust but still lacked deep contextual understanding. The advent of machine learning brought more sophisticated models like support vector machines and conditional random fields, CRFs, for tasks like sentiment analysis and named entity recognition. However, the real revolution arrived with deep learning. Architectures like recurrent neural networks and long-term short-term memory networks, or LSTMs, began to capture sequential dependencies, leading to significant breakthroughs. This shift moved us from explicitly telling computers how to understand language to teaching them how to learn its representations automatically. Today, the landscape of NLP is dominated by a particular deep learning architecture, the transformer. What makes transformers so powerful, it's primarily their attention mechanism. Unlike previous models that processed words sequentially, attention allows the model to weigh the importance of words in a sentence when processing any single word, capturing long-range dependencies and context much more effectively. This innovation enables parallel processing, speeding up training on massive datasets. This led to the rise of pre-trained models like BERT and GPT. These models learn vast amounts of language knowledge from enormous text corpora, essentially becoming experts in grammar, semantics, and even common sense. Once pre-trained, they can be fine-tuned with smaller, task-specific datasets to excel at specific applications, whether it's powering an advanced chatbot that understands complex queries or providing highly accurate language translation. In conclusion, natural language processing is a dynamic and essential field that continues to redefine how humans interact with technology. It's the engine behind our digital assistants, translation tools, and even creative writing AI. Looking ahead, we're seeing exciting trends like multimodal NLP, where models integrate text with other data types like images and audio to understand context even better. There's also a strong focus on ethical AI, particularly in addressing biases that can be inadvertently learned by models from their training data, and improving explainability so we can understand why an NLP model makes certain decisions. The journey in NLP is far from over. Continuous innovation is pushing boundaries, from real-time complex reasoning to supporting low-resource languages. Keep exploring these architectures and their ethical implications, as the future of human-computer interaction will undoubtedly be shaped by how well machines learn to speak our language.